Okay, let's kick off this training. Fundamentals of testing. This is section 1 based on the ISTQB Foundation Level 2018 version. And let's make a start. What we will learn on this section is basically what's in the ISTQB is, as it stands at the moment I record this, is the Foundation Level 2018 version. What is testing? Why test is necessary? The 7 testing principles, the test process, the psychology of testing. It is a lot of content. I would like to say this up front. Just try to take in by chunks. I recommend you take about 20 minutes and then stop, go for a walk, go for a glass of water, come back and take another 20 minutes. But this is how I recommend, but you know, each people have different preferences. I'll try to record in small chunks so you can watch. You have a beginning and end for each section, each part, but you can watch all the way through as well. It depends on how you like. But one of the things I'd like to say, and based on how it has enhanced my experience with as a tester or anything that I put my mind to learn, is that you have to trust the process. So everything has been put it on in such a way that the knowledge builds up. So you see things, you see, you have a glimpse of something at the beginning. I know you're going to have questions, but trust that it will get expanded at a later point. It is a lot of content, a lot of information, and it might be overwhelmed when you first hear it. Just go through and then just come back again and repeat and watch again. If you don't understand something, just repeat again and expand the search. I put a lot of content, expanded content in my blog as well, my website, that you can expand these. You can always ask questions as well and watch from different perspectives. So, and I like to put these in all my training. Every time I explain something to someone in videos or training, that you know, if you focus on the knowledge and the process, you will get the result that you desire. So just trust the process and let's go through it. What is testing? So it's the first part of the first chapter, first level of the ISTQB. There's a lot of content to go through. Right now I'm gonna focus on the what is testing, okay? And I quote these from the syllabus. So the software system are an integral part of life, you know, from business, you know, from e-commerce or consumer products that you consume every day. You'll know that software is everywhere. I bet you did and I did as well, and like everybody else, we always have that experience of something did not work as quite well as expected. That can lead to problems, to upsetting, to loss of money, loss of reputation, and in worst case scenarios, injury or even death. And software testing is essential. It's part of the overall quality of a product, and it helps reduce, you know, the risk of a failure. So hence, that's what software test is in a nutshell. We use software in one way or another. You use as well. We use software to build software. And like I said, you know, I bet that one of us must have come through an experience when you try to use an app or purchase something or fill in a form and that did not work quite well. And the way to mitigate this before you put it out there for the users to use is to mitigate this problem is to software testing. So we have software environments where developers develop and then publish in the test environment for testers to test. And also we have some beta users or business users or test users that are more independent from the development point of view to try out the system before it goes out live for everybody else to use. This is in a nutshell. I quote again, misconception of tests is that it only consists of running tests, like just going executing tests. It's not just about just going, click and press buttons. And in the syllabus, they explain this quite well as well, that saying that and they will follow on the ISTQB exam. There's this static testing as well. And that there's the planning, the analysis, all the things prior you actually going and see the system run, the UI level, or where you can go and press things. Okay, there's these activities as well that are very, very important before you get the actual product. It's much more than just go and press buttons. You don't just go and sit and say, oh, okay, I'll wait until the development is done, then I can go and press some buttons. No, there's other things that you can do before that, and this is quite important, and will fall on the ISTQB exam. So there are other activities like planning phase, analysis and design phase, the implementation execution, the exit criteria and reporting that you do, and then the closure, like say, look, all concluded now. As early as you get involved with it is better. Just always push for that. I know I've worked in some places that they avoid getting testers involved as early as possible, but it's good. You can help. It's a collaboration, and you can help asking questions. Why this, why that, how? And then it can help you start to understand, how am I going to test this before you actually get to see the product? Because by the time you get a product, you might have a short time window to test as well. So it is important to bear this in mind. There's much more things to do than just press buttons. Basically, that's what I'm trying to say, okay? And I'll explain these as we go through. Okay, yeah, so the 5 fundamental test activities and test tasks from planning to test closure, this is more from, I took these from the older version of ISTQB, but it's still valid on the new one. And the new one, they just split it out a little bit more, which I explain further down in these slides. But it can give you like a nutshell. And like I said, I like to repeat and to do repetition in different and explain different ways about the same thing, because that, I believe, it helps, imprint it in your subconscious mind. It becomes second nature. Planning and control. So planning, verify the mission of testing. Control, monitor, checks progress and take action. So at the analysis level, when you get the requirements and the information that you need prior to product start or as soon as you kick off. So the test analysis and the test design is the testing objectives to create the test conditions, the test cases and all the information that you need to prepare to design your tests. So how am I going to test these? And then, I'm planning to do these, and that. The implementation execution is the activity where the test procedures or scripts, if you are automation tester, are in order, and that the environment is set up and test run. So have I got all the test scripts that prior I start? Have I got it ready? Is the environment ready? And can I just, all the setup is ready for me to execute what I wanted to execute. All this verification is done at that level. Activity where the test execution is accessed against the defined objectives, where you evaluate the exit criteria and report. So have I run everything that I wanted to run, all the tests that I intended to? How am I progressing? Can I conclude what I'm doing? And also where you evaluate what you have been testing in terms of bugs and the discrepancies and clarifications and things like that while you're running the tests. Bear in mind that in the analysis part as well, you will do some questioning on the clarifications where you test the static test it is, which I explain about static and dynamic in the next few slides. In test closure occurs at the project milestones such as release completion, cancellation, or maintenance, which is very, very important. Maintenance, what's going to happen afterwards, after we deliver. And that's the test conclusion. Okay, so I quote again on the foundation level syllabus 2018. There's going to be a lot of quotes, which is quite important, so we know that we are following through the syllabus. This is quite important, and I expanded in further slides. The static tests and dynamic tests. So the dynamics test is where you go in actually using the system. You test the components of the system, you test the end-to-end, the functional of the system, and there's other test that does not involve the execution of the component or the system, but you do other type of tests, which is checking the documentation, peer review the code, and look through the code as well with the developer, and that's called the static testing. Testing also includes reviewing work products such as requirements, user stories, and source code. These will fall in the ISTQB exam. Okay, remember this bit. Yeah, dynamic testing. Just put some graphics here just to kind of show you and help you memorize as well. I think we are humans, we are better memorized with some images rather than text. And like I said, I will repeat many times in different ways and talk about the same thing. So I'm talking about dynamic testing and static testing, but taking out, extracting from the syllabus. So software testing can be divided into static testing and dynamic testing. So the static testing is anything related to reviewing something, like a documentation or talk through, an email, a request, a conversation, a walkthrough, someone like explaining something and showing like, oh, this is the idea, this is what I'm thinking, and I'm thinking in design this and this and that in that way. And also the inspection, where you look in more details on the final defined documentation, where it has been signed off by the business, say, look, this is what we want. And dynamic testing, it's the functional and non-functional, which it will be again expanded in further slides. So don't worry too much about it right now. Just have that in mind, that when you dynamically testing something, there's the functional test and non-functional test. Further down, another quote. Let's just move these out of the way there. So another common misconception of tests is that it is focused entirely on verification of requirements, user stories, and other specifications. While tests does involve checking whether the system meets specified requirements, it also involves validation, which is checking whether the system will meet users and other stakeholders' needs. So there's no point in build something that it works, there's no bugs. Okay, so the system you can log in, you can go through it, you can fill in an application, you can submit something, or you can capture all the information that you need to capture in the system without crashing. But in the end, the business user don't accept or doesn't like, because it's not the way they envision to be using. So there's this part of quality check that you need to have in mind as well. When in the exam ask you about, are you just doing validation verification? No, but there's something else as well. So does it meet what the stakeholders expected to be delivered? And that's something that a quite tricky question that they ask, but just have that in mind. Again, just a little bit graphically of what we just talked about now, about so the user and stakeholders' expectation. They speak with product owners, they produce a documentation with the architect and the BA, and write the specification. And then based on the specification, that's where the developers and the tester work on from, and goes through the process of the development lifecycle and delivers a product. Between these processes where you do the validation based on the specification, right? But when the product is delivered, does it actually meet what the stakeholders expect it to be? And that's where the verification part is done. You can get involved in that as well, and you should. Some places don't want to testers to get involved in it, but it's I personally think it's really, really important. And again, don't get just trapped on just doing the analysis. You can get, it can be endless in analysis. Just do enough to get the acceptance criteria signed off by the business, and then work against that acceptance criteria. You will notice that sometimes you want to go beyond, but you can't because of time, budget, time constraint, or the budget is limited, or the time it's beyond the scope, basically. Okay, so another quote. Identify the typical objectives of testing. It's good for you to kind of try to memorize as much as you can out of these. So basically, the objectives are to prevent defects by evaluating work products such as requirements, user stories, design or code. Verify whether all specified requirements have been fulfilled. Check whether the test object is complete and validate, if it works as the users expected. To build confidence, so it's essential part, and you're going to be asked like, oh, how do you feel about these? Are you confident about these? And then you have to express your opinions and feelings based on facts, of course, of the product. How confident are you with these after your test is complete? Trying to find defects and failures, that's the number one thing. It's not the only one, but it's the number one thing that you wanted to measure your work, is to find defects and failures and to prevent them as well. It's not just about create a list of bugs and defects. It's about how can I help to prevent that and work as a team on the quality and minimize the risks and identify those risks as well, and help it how to mitigate those risks. And to provide sufficient information to stakeholders. So you wanted to give them facts and help them take an informative decision. And you help provide that information, especially around the quality of the system. And really important, does it comply with contractual or legal or regulatory requirements or any standards that needs to be? So I do have clients that government body where there are certain laws that get changed, and you have to comply with certain requirements. And this is like an essential part of the test as well. And I don't know if you remember a few years ago about GDPR. If you are in Europe, and I am in Britain, United Kingdom, so GDPR was a big thing. So I think there's an equivalent to that in America and in Brazil as well. But yeah, it's something that you work around. Does the system meets that standard? Okay, so a typical objective of testing, a little bit graphically again, so where those testers get involved. So at unit test, you would have tests that mostly done by developers, but testers can get involved as well. If you are a tester with coding skills, you will get involved in the unit test as well, but mostly are by developers. And then after the units, then you have the component test, ensure that each component works as specified. And then after you test those components, then you test the integration of within these components. Then you have the integration tests, ensure that each component works together. And then once that is complete, then you system test. And then you have the system test, where under the system test, you have the functional test to verify the functional requirements as, are they satisfied. Quality test verifies non-functional requirements. And like I said, I'll expand this a little bit more about functional and non-functional in further slides. And then after that, then you have the acceptance test, where the users of the system, if you work for a business and then you have internal system, then you invite the business users to check and verify all the requirements that they asked has been put in place. And then the installation test environments are set up correctly, and it has been deployed as expected. And then it goes out for the system is ready to use. Another quote, I'm not going to read all of it, but basically the objective of testing can be around the context of the component or the system being tested. And during the component testing, the objective is to find the bugs and find failures and then help fix that earlier This is one of the objectives around the component testing, and make sure all the coverage has been complete at that level. And the acceptance testing, which is a different objective where you invite more users to get and use the system, is the objective is more of has the what we asked for has been delivered. It's more of like a verification and the confirmation that okay, so yeah, I've got everything that we asked for, and therefore I'm signing off for you to release, so we can start to use these in production. So there's these two objectives that is distinctive based on where you're more of a component and more acceptance. You want to avoid and rectify errors, ensure that the key functional and non-functional requirements are examined. Testing is not about removing defects. I did mention this before. It's about notifying developers in the team about it and say, look, I came across these are the steps to reproduce. This is what I found. This is what I think it could help release. Here are the facts. So we don't, testers don't fix it. We just report and present the facts. But it is also about reducing the risk to go to a release with something broken. What testers can do can give you and help give you the team confidence about the quality, the overall quality of the software. If there's known defects or just a few defects, there are defects that are accepted to go live. This is normal. I don't think there's any system that are defect free. Testers can and must be measured, and I'll talk about this in further slides as well. And these typical measurements, and not limiting just in this list. Okay, there's more ways, but these are the main ones. Number of defects found, number of failures in any given time period, you know, how much reliable the system is, the usability rating as well. And most important, I think one of the most important is maintainability, how much maintainable this system is after goes live. Just a quick one, an example. I like to work with Dynamics 365, CRM and ERP. Both products, they have releases. It is an out-of-the-box system, but most companies, they customize, and Microsoft allows them to customize it, to get customized, but you have to follow some best practices recommended by Microsoft, because there are updates. And Dynamics CRM specifically, there's 2 upgrades a year, April, October, Wave 1 and Wave 2. As part of the test, you wanted to make sure that whenever it's customized, can you think about the maintainability as well of that customization in a way that whenever it comes the upgrades as well, can these be a problem in future? How do we find out that? How we just open the discussion and talk about these topic about maintainability, how maintainable these change that we put in place now in a project or enhancement or customization or integration of an external tool can have an impact on the system, and that's quite important. Yeah, so differences between testing and debugging. So you might or may not have heard about this, but here it is. So debugging is a process used to identify causes of bugs, code, and correct them. And testing is the exploration of the system in order to find the defects. Each one on your role. So dynamic testing, where you go and use the system, the tester observe the failure and says, oh, look, I'm just reporting this incident. And the developer accepts that information, and then it goes following you steps to reproduce all the information that you captured and investigate and isolate the defect, fix the defect, check if it works. They have to do the check as well, and then report back and says, look, I fixed it. There you go. Can you just retest? Developers don't close the book. They pass it back to the tester to go and retest it again. And then once the tester is happy that, okay, so yeah, seems like it has been fixed, and therefore it's no longer a bug, and then close the bug. Okay. The testing side is it's the part where you carry out the verification validation of the system. Make sure it's following the development life cycle best practices and rules that and it goes against the requirement as well, normally written using a user story. And the testing is just to ensure that intended software does not have any bugs or malfunction efficiently while handling all boundary cases and unusual conditions, as well as exceptional cases or rare events that you might find when you're using the system. Debugging, again, it's the part where the process of debugging software applications can be tedious and complex, and involves identifying, analyzing, solving errors in every stage of the execution. So it goes step by step. So there are tools that can be used like Visual Studio. There are other IDEs out there, IntelliJ and many others. But in Visual Studio, you can set the code to go step by step until you find and you go back and until you pinpoint exactly why the failure is happening. There's a lot more about debugging. Debugging works by pinpoint bugs, then fixing them one bug at a time, and compare the expected results against actual outcomes to see if there's discrepancies or errors. Yeah, this point as well that I like. Debuggers often comes across impossible errors, which they cannot debug because they cannot be found even after intense troubleshooting efforts have been made. This is what like programmers and developers call the structural defects or design flaws. Sometimes you come across a bug that it only happens sometimes. We call it intermittent issue, but yeah, we will save it, put in the backlog and observe. And when you come across again, then you get the team together to work on that one and see if it can reproduce that condition to pinpoint that issue. But again, we collect the information, we expose, but the debugging process is done by the developer. Okay.